Right, let's talk about one of those words from chemistry class that probably made your eyes glaze over, the mole. It sounds super intimidating, right? But what if I told you it's actually a pretty simple and kind of brilliant idea? Stick with me, and I promise, we're going to make this make sense. Okay, so to really get why the mole even exists, we have to put ourselves in the shoes of an early chemist. Imagine this. Your job is to mix stuff together, but the stuff you're working with, atoms, molecules, is completely invisible. I mean, how are you supposed to follow a recipe if you can't even count your ingredients? Now, seriously, think about it. How on earth do you weigh a single atom? You can't just pick one up with tiny tweezers and plop it on a scale. It feels like a total dead end, right? An impossible problem. And here's where it gets really mind-bending. Just one single drop of water has more molecules in it than there are stars in our entire galaxy. Let that sink in. So counting them one by one? Yeah, that's not just hard, it's just not gonna happen. Ever. Clearly, chemists needed some kind of genius shortcut. And the solution they came up with is actually something you're already a pro at. You use this exact same idea all the time without even noticing. It's basically just a special counting word, a way to handle these insane numbers. Think about it like this. When you go to the store for eggs, you don't say, I'd like 1, 2, 3, 12 eggs, please. Of course not. You just say, I'll take a dozen. Dozen is just a handy word that means 12. Simple. Or, hey, what about paper? You need 500 sheets for the printer. You don't count them out. You just grab a ream of paper. Again, ream is just our easy-to-say label for the number 500. You see the pattern here? Dozen, ream, a pair. They're not complicated. They're just nicknames for a number. They're shortcuts that make counting big groups of things way, way easier. So that brings us right back to our chemist. If a baker gets a dozen and we get a ream of paper, what's the chemist's special counting word for all those tiny, tiny particles? And here it is. The chemist's dozen is the mole. That's it. A mole is just a name for a number. It's a really, really big number, sure, 6.022 times 10 to the 23rd, but at its heart, it's just a counting word like dozen. So yeah, the textbook definition says a mole is a unit for a large quantity of particles. But you know what? Just think of it like this. A mole is the chemist's dozen. It's just a dozen that has to be ridiculously big because the things it's counting are ridiculously small. Okay, let's just pause for a second and really try to wrap our heads around how huge this number actually is. It's kind of mind-bending. And remember, the only reason we need a word for a number this big is because atoms are just so unbelievably tiny. Look at that. That's it written out. All those zeros. It's called Avogadro's number, and it's a number so big our brains aren't really built to understand it. We're talking 602 sextillion. What does that even mean? Well, let's try to put it in perspective. Imagine you had a mole of basketballs. Not atoms, basketballs. You would have enough basketballs to create a brand new planet, the same size as Earth. Seriously, that's how big this number is. Okay, so the mole is a giant number. Got it. But that's not even its coolest trick. The real superpower of the mole, the thing that makes it so genius, is that it connects that insane number of things to something we can actually measure, something like weight. This is the whole point, right here. The mole is like a magic bridge. On one side, you have the invisible world of single atoms, which we measure in these teeny tiny things called atomic mass units, or AMU. On the other side, you have our world, the lab, with scales that measure in grams. The mole is what lets us walk from one side to the other. It's the ultimate conversion key. And check this out. This is how beautifully it works. Take a look at carbon. A single atom of carbon has a mass of about 12 AMU. Now, what if you get a mole of carbon atoms? Its mass is 12.01 grams. The number is the same. All you do is swap out AMU for grams, and it works for everything. One oxygen atom, 16 AMU. A mole of oxygen atoms, you guessed it, 16 grams. It's perfect. This makes a chemist's life so much easier. You literally just 1. Look at a periodic table. 2. Find the atomic mass number. And 3. That number, but in grams, is exactly how much you need to weigh out to get 1 mole of that element. That's it. It's that simple. So, you see, the mole is way more than just some crazy big number. It's the most important bridge in all of chemistry. It connects the idea of an atom, something we can't see, to something we can actually hold and weigh in our hands.
So, what's the big takeaway? Why is this whole thing so essential? Well, because of the mole, we can finally count atoms just by weighing them. It's the link between the invisible world and our world. It's the foundation for literally every chemical reaction, every recipe. Without the mole, there's no modern chemistry. Period.
Look, if you remember just one thing from all this, let it be this sentence. The mole turns an impossible counting problem into a simple weighing problem. That's its genius.
So I'll leave you with a little thought experiment. Right now, you know what a mole is. So how many moles of water are sitting in that glass on your desk? The cool part is, you now have the tools to figure that out. All you'd need is a scale, and that is the incredible power of the mole.